Hey there, folks. So today I'm going to be going over something pretty cool I did on my computer. I set up a more or less from scratch cloud backup solution for my home Linux system. I set up a virtual machine as a backup server running on Microsoft Azure Cloud, connected my system to that, and can run automatic and incremental backups to that server. What that means is it's automatic. It runs at an interval that is specified by me, and it's incremental, meaning that one big snapshot is taken at the beginning, and then every day only the files that are changed or edited or new are backed up, and I am left with snapshots of my machine throughout different days, but each file is only backed up once. Now, I will say, if you are looking for like a good way to have cloud backups of your Linux system, this is not the best way to do it. This is a cool way to do it, but it is not the best. There is cheaper and less convoluted and just simpler ways to do this. What I personally use is Backblaze B2 storage combined with Duplicati. Just a brief rundown on that so I don't get too sidetracked. B2 storage is like bucket storage. You can think of a bucket essentially like a big hard drive in the sky, like it's just a place where you can put files. And what Duplicati allows me to do is it streamlines the process of like specifying what directory I want to back up, encrypting all of that data, and then sending it into the bucket. So for example, if I go and look in this bucket, all it is these like 50 megabyte chunks of encrypted data all the way down. But then Duplicati streamlines the process of, if I want to do a restore, it will decrypt everything and I can look at my whole like original file structure and select everything that I want to back up. It also has retention rules, so you can maintain, daily backups for a certain amount of time, weekly backups for a certain amount of time, and it just streamlines that process. That's good for a bunch of different reasons. For one thing, if someone were to get access to my Backblaze account, it's kind of like, congratulations, you don't actually really have anything. You just have all this encrypted data. Also, if you're backing up to somewhere like Google Cloud or something, or Amazon, somewhere that's most definitely going to use the data in there to sell to advertisers, or use for their AI training, or just use for who really knows what. And if you're not super psyched on that idea, then if you send Google Cloud just 50 megabytes of encrypted data, they can't really do nothing with that. So it kind of maintains your privacy while still having a cloud backup. So don't let me get too sidetracked into that. If that's what I recommend looking into, Backblaze B2 bucket storage and Duplicati, or bucket storage of any type, and a service like Duplicati. Rclone is also good. It doesn't do encryption, but it streamlines this process. Okay, I'm getting sidetracked. I don't want to get sidetracked. So it uses hard links, which is the same thing that, if you're familiar with TimeShift for Linux, how TimeShift works, it's the same thing as that, where, TimeShift will store like an entire snapshot of your system every day, but like only the files that you have changed are new. And the way that works is by using hard links. Now, what hard links are, as opposed to soft links, are, for example, if I were to, let me just demo this. If I were to create this file, touch LMAO, if I were to go and then look at that file, LMAO, if I go and run an ls-li, the I will show the inode of that file, and it has this inode. Now, what this essentially is the inode is telling the operating system where to look on my hard drive to find this file. Now, if I were to go and create a copy of this file, put it in Documents, and then running ls-li on Documents, you see I have this file here, and it has a whole new inode. Now, it's exactly the same file, obviously. I just copied it. But what happened, is the whole file is now copied to a new location in my operating system, as well as a new location on disk, and I now have two separate copies of this same file on disk. What a hard link would do basically is it would make a copy of this file in my operating system, but the inode would just point back to the same location as before. So that way I can have 2 copies of this file on my operating system, but only 1 copy on disk. And that is more or less how a system like TimeShift works, where, you know, I could, for example, back up like my whole documents folder one day, and then let's say the next day, like I add one more file, LMAO2. So then tomorrow, my whole documents folder is the same as the day before, except for this one file. And so then the next day when I back up my documents folder, it will, and if I were to go then and look in my documents folder, it will show all those files that were there that day, but the files that were there in previous backups will just be sharing the same inodes, will be hard linking back to the files that were already on disk. So that way I can view my documents folder as it changes throughout the life of its backups, but I only have to store each file one time on disk. And in this case, because it's a cloud backup, it's helpful that I only have to back those files up over the network one time, which is good, because obviously if I were to be backing up, 20, 30, 50, 100 gigabytes for each backup over a network, that would be slow and it would be a pain in the butt. So let me give a basic rundown of kind of what's happening. So what we are doing is we are creating a virtual machine in Microsoft Azure Cloud. Let me enlarge this, by the way, so it's easy to see on phones. We are creating a virtual machine in Microsoft Azure Cloud. Azure is Microsoft's cloud platform. We are then mounting a folder from that virtual machine using network file sharing, or NFS. We are using NFS to mount a remote folder from that virtual machine into our local machine as if it is a local folder. And then we are using Rsync to create backups to that mounted folder. And Rsync will also take care of making the hard links and figuring out what files need to actually be backed up and what do not. So it's a pretty simple process once you know how to do it, but it does take a little bit to get everything set up in Azure. And I had a good time I sort of did this project to just kind of learn more about cloud concepts. I was kind of learning about Azure and stuff like that. And I just decided, like, what could I do with this? Like, let me figure out a way to make backups here. Cause I was kind of wanting a good cloud backup solution for my system. And I knew that there would probably be an easier way to do it, but I just kind of wanted to learn more about Azure and just different cloud computing concepts. So if you also would like to learn more about just cloud infrastructure and that sort of thing, everything that we're going to do will be free, because Azure, as do most cloud providers, provide like Azure provides a $200 credit to use within the first 30 days for new accounts. So everything, that'll more than cover everything that we're going to do. If you do want to run this as like a long-term backup solution for whatever reason, it's going to cost you anywhere between like $15 and $30 a month, depending on how much storage you want. As opposed to like Backblaze, for example, charges, I think, like $5 per terabyte. And for my Backblaze currently, I'm only using about, I think, like 30 gigabytes. So it's a lot cheaper that way. But if you just have the money to spare and you think this is cool, you can use this as like a long-term backup solution. Everything will be fine. It's just more cost intensive. So with that being said, we'll get into it. The first thing you got to do is hop over here to azure.microsoft.com and make yourself an Azure account. You can just hit get started or try Azure for free. And if we pop down, as you can see, yeah, you get a $200 credit to use within the first 30 days. Very cool. So go in here, make your Azure account, get that all dialed in. And once that's all dialed in, you can pop over to portal.azure.com and log in here. When you first log in, there won't be any of this stuff here because you haven't created anything yet. This will just be blank. So once you get into the Azure portal, you're just going to want to go over to create a resource. Once you're in here, you're going to hit create a virtual machine. It'll take a second to pull up the page. And now you get taken to this whole like virtual machine setup wizard, which is very cool. Most of the stuff you can leave as default. Subscription, you can leave that as it is. You should only have one. Resource group, we're going to create a new resource group. We'll call it backup-server. Resource groups are ways essentially of like grouping certain resources that are related to a similar project to make them just kind of easy to manage and keep them all in one place. So we're going to name that backup server. Virtual machine name, we can call it backup-server. Region, choose whichever one is closest to you. West US 3 is fine for me. Availability options and availability zone, you can leave those alone. This will essentially put like if I were to select like zone 2 and zone 3, this means this is mainly used in like production environments. If, for example, if you're running like a web app or something and like one Microsoft data center were to go down and that's the only place where your web app was, your web app is going to be down until you move it over to a new zone or until that data center comes back up. If you have multiple zones, then it's like even if one Microsoft database goes down, you're still going to have availability for your web app. You could do this if you're like really concerned about availability for your backups or whatever, but it will like multiply your costs because you're literally running everything twice or 3 times. So we're just going to leave it on zone 1. Security type is fine. Image, I'm going to use Debian 11 just because I'm most familiar with that operating system. Ubuntu server is obviously also great. You'd be fine using that. And if you used Ubuntu server, everything in this guide will be basically the same. We really only need to install one package, right? Yeah, I think we just need to install 1 or 2 packages on the server, and they have the same name from Debian to Ubuntu. If you decide to use SUSE or RHEL or Oracle, everything in this guide will still apply and still be the same. You'll just have to figure out the different package name for the 1 or 2 things we need to install. So yeah, so I'm going to choose Debian 11. Down in size is like the different like tiers of VMs, like how powerful they are. You could go into see all sizes, and there's a whole bunch of different sizes. There's a whole bunch of different like lines, like there's the B line, D line, A line, that are all kind of like designed to do different things. For our use case, the B1S, the default one, should be fine. That's just like a general computing type VM, 1 CPU core and 1 GB of memory. That's plenty. Debian 11 base install with no desktop environment like we're going to be doing uses about 150 megs of memory. So this is plenty enough for us. So yeah, so that's the size we're going to choose. Authentication type, I'm going to leave it on SSH public key as opposed to password. This means like if you were to choose password, this means that you can SSH into your virtual machine using a username and password. SSH key is going to mean that you have to use the SSH key. The reason why I'm going to choose this is it's generally considered a more secure and just a better option. The reason why is I mean, you'd have to be a silly goose to make this go wrong, but if you were a silly goose and you were to expose your SSH port just to like the open internet, what will happen, I've done little tests on this just to like watch it happen. What will happen if you expose your SSH port to the open internet is within an hour, 1,000, 10,000, literally bots from around the internet will start trying to brute force your username and password to your machine. Granted, if you use a strong and complicated password, like something from a password generator, or there's a dog barking his head off outside. I hope you don't hear that. If you use a strong, the likelihood of those bots being able to brute force both your username and your password is basically negligible. But I mean, for one thing, it's going to kind of bog down your network connection, which is, no good. And also just like, why? Like, what? Why just let a bunch of bots brute force your password? If you have SSH public key, that will not be possible because there will be no option to enter a password. So that's good. Again, if you configure this VM securely, which we will go through, this won't be exposed to the open internet. There will be no bots able to access it. But just as a good practice, we're going to choose the SSH public key. So over here in username, this is going to be the name for like the primary user on your virtual machine. I'm going to make backup user. The SSH public key source, I'm going to keep it on generate a new key pair. You can give it like an SSH key that you already have if you want, but I'm just going to leave it as this. Key pair name, we'll name it like backup server. Inbound rules we can leave alone. We're going to allow SSH. We will be modifying this down the line because the defaults in this use case are not as secure as I would like them. So next, we're going to pop over to disks. For the OS disk type, we're going to change it from a premium SSD to a standard HDD. This is essentially a crappier hard drive. The reason why I'm doing this is it lowers costs, and especially for our backup disk, which we will make also like a standard HDD, because we're backing up over a network. Like for me, I get like 10 megabytes up, or megabits, is it? I don't know. I always get confused on that. I get like 10 megabytes up, which is far and away from saturating even like an old school SATA mechanical hard drive. So choosing just a standard HDD is fine. Then we're going to go down here and to create and attach a new disk. Once you're on this page, you're going to go and hit change size, change the storage type down to a standard HDD. I'm going to select 64 gigabytes for size, because I'm only backing up my home folder to this backup, because if I need to like restore like, you know, user lib and /var and like all that other like system files, essentially, it's probably because I broke something, in which case I need to like restore my system back to before I broke it. In which case I'm going to use something like Timeshift that will just, you know, have snapshots of my system from the day before and stuff like that. If I were to do a full system restore, like over a network, that could take a long time and be kind of a pain in the butt. But I'm using this for like this sort of backup for us, like for like files and, you know, notes and documents and pictures and stuff like that. So I'm really just backing up my home folder. My home folder currently is around 30 gigabytes. So I'm going to choose 64 to kind of give it some breathing room. One thing to keep in mind here is Azure will let you expand the size of hard drives, but never decrease it. So it's better to kind of like choose, you know, around what you need now and then expand later, rather than just get stuck paying for a 500 gigabyte hard drive when you really don't need that yet. So we're going to hit OK. We're going to hit OK again here. And then we should be good on this page, right? Yeah. So then we can hit next into networking. Now, this page is very important. This is going to play a large role in like the security and the network security of your virtual machine, and by proxy, the backups of your entire local machine. If this page is configured insecurely, you are toast. So what we're going to do is we're going to come down into NIC Network Security Group, hit Advanced. We're going to come into Configure Network Security Group and hit Create New. I'm just going to delete this default inbound rule and then hit Add an inbound rule. For source, you can come down and hit My IP address. Now I will have this blacked out in the video for obvious reasons. But right here will be like your public IP address, not this thing, not the 192.168 IP address. That's your local IP address in your home network. This is like your public facing, like this is like your router's IP address. Now, one thing to keep in mind, I don't know if I'm doing something wrong or if there's a bug or something, but if I hit my IP address and then I were to like add this rule, see back here where it says any, it should have that IP address, but it does not. And then when I click the rule again, the source has defaulted back to any. I don't know if I'm doing something wrong or what's up with that, but what you got to do is hit my IP address. Your public IP address will appear there, and then you can just switch over into IP addresses, and then your IP address will stay there, and that is good. Source port ranges you can leave as an asterisk. This is going to be the port from your local IP that is going to be used to contact the virtual machine. And you never know what port your local machine will decide to use to contact the virtual machine. Destination can be left to any. Service can be left to custom. And destination port ranges, we're going to go 22, 111, 2049. Now, port 22 is SSH. Port 111 and 2049 are used for network file sharing, for NFS, which is the thing that we're going to use to mount the remote folder. We can hit TCP protocol because we only need these ports on TCP. And then for priority, we're going to hit 100, 100, give it a pretty high priority. The lower the number, the higher priority, because we want this rule to definitely not be trounced by any other of the default network rules that Azure creates. And then we can not change the name for some reason. I don't know why I can't change the name. That is kind of annoying. Okay, whatever. Anyways, so what this rule is doing is it is saying that this IP address is allowed to contact this virtual machine on ports 22, 111, and 2049. No other IP address will be allowed to contact this virtual machine, and even my home IP address will only be allowed to contact it on these ports. Granted, you could leave this destination port range as like an asterisk because, you know, at this point, only your home IP address is going to be contacting the virtual machine, and you're generally fine, but you never know what like the slightest security misconfiguration can kind of snowball into. So, you know, principle of least privilege, you're just going to want, like, I only ever need to access these ports, so I'm not going to open it up to any more than that. So once this is configured, you can hit save, and your resulting thing should look something like this. The black bar should be your public IP address. It should look something like this. And then you can hit OK. We should be good on this page. Yeah, we don't need to worry about load balancing. Management, you can leave as default. Monitoring, I'm going to enable recommended alert rules, and you can just leave this as default. Basically, this is, if it loads, there it goes. Basically, if your virtual machine is like acting funky or something, it'll shoot you an email. So we're going to save that, and then go over into advanced, which we can leave as is. Tags, we don't got to worry about. And review and create. Azure is going to go over your settings, validate them, make sure that everything like checks out. Once the validation is passed, we can hit create. This is where you will also get a download for your SSH key. So we're going to download that. It should, there it goes, downloaded. And then we're going to return, and it is going to deploy the virtual machine. Very cool. This can take up to like a few minutes to deploy, so I'll just resume the video once it is done deploying. So our deployment is complete. That is very cool. Next thing we need to do is we can click on go to resource, and we need to grab the IP address of this virtual machine. It should load up in a sec. Why is it not loading up? I'm going to have this blacked out, but your public IP address for your virtual machine, will be right here. You can just hit copy to clipboard. And from there, you can come back into our terminal. And I'm going to move my SSH key into just this directory right here. You're going to want to chmod 600 your backup server, your SSH key, because SSH does not like any permissions on SSH keys over 600. And then we can go and hit ssh-i backup server.pem backup user, that is our username on the virtual machine, and then the IP address of it. You should be asked if you want to accept the fingerprint. I do indeed. And bada bing, bada boom, baby, look at that. You're now on our virtual machine. Very cool. Who doesn't love that? For ease of use, I'm going to add this virtual machine into my Etsy host file. Yeah, so you can just run sudo vim Etsy hosts. Come down into here. I'm going to paste in that new IP address, and we'll call it like backup dash, like a type good, backup dash video. If you're not familiar with the Etsy host file, this basically just means that like when I type backup dash video into like the terminal or something, it'll automatically resolve to this IP address. So it just kind of makes things a little easier. So we're going to save that, and like for example, if I then were to go ping backup dash video, you see it will ping this IP address. We are not getting any responses from these pings because, again, we did not enable, we disabled like responses to ICMP requests. We can only contact this virtual machine on TCP ports 22, 111, and 2049. So that's why the ping's not working. But yeah, so then that just makes it easier. I can go backup server at, let's go backup dash video. Oh. That is interesting. Let me troubleshoot that. Okay, I'm not entirely sure, but I think SSH just does not like that I'm now using like a different host name for the machine over rather than the IP address. I think if I just add this to my known hosts file, then it should work. Yeah. Yeah, okay, cool. So very cool. So now we are on our virtual machine. First thing you should always do on like new virtual machines and new installs is just upgrade everything, make sure all the packages are up to date. There shouldn't be too many packages. Yeah, only 2 packages to update because, you know, Debian's not a rolling release and it's Debian 11, so it's getting a little older now. And it looks like it's just, yeah, some firmware stuff, some Hyper-V daemons. Yeah, so that should upgrade pretty quick. I'll resume the video once that's done. All right, and then it just wants me to run this systemctl command. So we shall do that. Cool. So then we need to install the NFS server on this machine. So I think, what is that called? Let me go check what that's called. I have it written down over here. Yeah, nfs-kernel-server. Oh, install, very important. Bam, we'll install that. Very good. All right, and then as you can see here, it's created this new etc exports file, which we're going to need to edit right now. So we'll go sudo vim etc exports. I love, by the way, that Debian comes with Vim installed. Not all distributions do. I don't know why. I'm going to want Vim. You know what I'm saying? Just give me Vim. Anyways, sudo vim etc exports. We can come down to the bottom here. And then we're going to add a line. What this folder is doing, what this file is doing, is it's telling NFS, network file sharing, what folders we want to share and with who. So we want to share, actually, before I do this, just kidding. First, before you add the exe exports, you're going to want to make a directory that you want to share with your local machine. So this is going to be the directory. I'm going to share this backups directory from this virtual machine back to my local machine, and I'll be creating my backups to this folder. So now we'll pop back in here, and then we will go and we will share the home backup user / backups folder, and we're going to want to share it with our local IP address. So this is that thing. If you come in here, this is the thing we gave to Azure. This is like your home IP address of your router. I'm going to black mine out, obviously, for obvious reasons. But you can come to one of these sites, you can just like search like what's my IP and grab it. I don't have mine memorized. So we're going to share this folder with this IP address. And then the rules we're going to want to share it with. We're going to want to go RW for read write, async. Did I spell that right? I did not. Async, and then no subtree. If I could type, man. I swear, my microphone's like in front of my keyboard and it's messing me up. And no subtree check. What these options do, RW is read write. So that means that this IP address, it can read and write to this folder. Async. Async should technically not be used. Like if you're in like a production environment with like highly critical backups or something, you should not use async because it can cause you to like lose data. What the reason why I'm using it in this scenario is it will speed up performance a little bit, and I think it's just worth it. For one thing, what async does basically is it allows the NFS server to violate the NFS protocol, meaning that what can happen is your NFS client, which will be our local machine that is doing the backups to this virtual machine, the virtual machine being the NFS server. So the NFS server is allowed to respond to NFS requests before data has actually been written to disk. So the NFS client will go, hey, we want to back up this file. We want to send this file over to you. And the NFS server will go, okay, great. That's super cool. We got it. Let's move on to the next thing before that file has actually been written to disk. And so what can happen is if like the NFS server or the NFS client were to crash before like that file does end up getting written to disk, it can get like lost. It'll just die in the ether. And so the reason why I think that's fine is, for one thing, I find it kind of unlikely that our like highly minimal Debian 11 stable virtual machine will be crashing all that often. For another thing, we're using hard mounting in NFS, which is the default, meaning that like if the NFS server were to crash in the middle of a backup, the NFS client will just kind of hang and just wait until the server comes back online and just resume the backup. So that's cool. And also, like, if like a backup were to fail, like, I can just run another backup like immediately afterwards and generally be fine. So in this case, I think this is fine for me. If you don't want to do that, you can just remove the A and just go sync, and bada bing, bada boom. And again, if you're like a sysadmin in like a highly critical environment, this is technically like a more risky setting, but it does speed up performance. No subtree check is just another thing, again, to kind of speed up performance. What this basically does in a succinct way, if you were to have, what am I doing? Instead of subtree check, if you just had subtree check, this means that it will check, like the NFS server will check that the NFS client has permissions to access each of these folders leading up to the shared folder. So like, for example, if backups were in like /root and this user on this machine does not have permission to access /root on the virtual machine, it will like throw an error or do something funky. But if you hit no subtree checks, it won't check that. This could be in /root and like it would just be like, okay, whatever. The reason why we're doing this is that bypassing those checks, like, will just kind of speed up performance because the NFS server doesn't have to. It's just less stuff for the NFS server to do. So that is why, that is an explanation for all those settings. So then we can just save and quit out of here, and then we're going to want to run sudo export fs -arv. I think that's the command. Yep, that's the command. And this folder will now be shared with our IP address. So now we're going to want to pop back over. I guess I can just exit out of the SSH. We're going to want to pop back over to our local machine. And you are going to want to, I obviously already have it installed. You're going to want to install sudo nala install, what is it, NFS common. Nala, if you don't know what Nala is, it's just a front end for app, essentially. It kind of speeds up apt and just gives it a prettier interface. So you can also just run like sudo apt install NFS common. All the syntax is the same for Nala as far as I know, for all like the most common stuff. So you're going to want to install the NFS client package on your local machine. And then you're going to want to create a folder on your local machine where you want to mount the remote folder from your virtual machine. I just paused the video real quick to kind of undo some stuff, to kind of reset it to like before I had done this. You're going to want to go sudo make dir /media /backup. You can make this folder anywhere. You could just make it in your home directory and like /mount. You can make it wherever you want, /opt. Doesn't really matter. I'm putting it in media because that's like where like external hard drives and stuff live. And so I don't know, I'm putting it there because it's like an external hard drive where my backups are, except the hard drive isn't a hard drive. It's actually a virtual machine in the cloud. I don't know. Makes sense to me. That's where I'm going to put it. So we're going to make a directory there. And then we are going to want to mount that remote folder from our virtual machine. So we're going to go sudo mount -t, oops, not mound, silly goose, NFS for backup -video. Looks like I already done this before. Home, the remote folder, so home /backup user /backups, and then the local folder where we want to mount it, so /media /backup. So we run that, and we should then be able to go into /media, and we should have that folder. Let's go over SSH into our remote machine. Let me zoom this in a little bit for you guys. Backup -user at backup -video, right? So if we go into our backups folder, now if I create a file here in that backup folder, yep, I can see it on my local machine. If I, for example, create a file on my local machine, I should be able to see it on my remote machine because this folder is now shared with us. So that's very cool. So the mount works. What we're going to do though is I just wanted to like test that it worked and made sure everything was good. What we're going to do is add that remote folder to our etc fs tab, which just means that like that remote folder will be mounted to our machine on boot every time. Do keep in mind, if you eventually power off your virtual machine and you're no longer using it, your machine, like your local machine, will like hang for a while on boot up because it's like booting and it's trying to mount this folder that it can no longer access. And at least for me, like it would just like spend an extra like couple minutes like trying to mount this folder, and like there was nothing I could do about it, and I just had to sit there and be like, okay, dude, like the folder doesn't exist. You know what I'm saying? So do keep that in mind. There are some ways to mitigate that. But yeah, so the next thing we're going to do is we're going to go sudo vim etc/fs tab. Actually, before we do that, we're going to unmount this. So we're going to go sudo, what is it? Umount, yeah, -v media backup. So then we'll pop back into our fs tab. I have these commented out from times before. So then we're going to add the remote IP address. Where is it? The remote IP address of our virtual machine right here, and the remote folder that we want to back up. And then we're going to enter the location on our local machine where we want it to live. We're going to enter NFS4 because that is the NFS protocol we are using. And then these are the settings for the mount. We're going to go default/user. I guess we should probably go no auto, actually. That would kind of mitigate what I was just talking about. Defaults just tells NFS to just use all like the default settings it usually has. And then these are like the settings that we're changing from the defaults. So by default, this would be no user, which means that only the root user can mount this remote folder. Changing it to user means that a user account can mount this remote folder. And no auto means that the folder will not be automatically mounted. It will only be mounted once you try to access it. So this will like speed up, not speed up. It will slow down. Like once you eventually do try to access it, you'll have to wait a second for it to mount. Really not that big of a deal. And it will, like, if there is an error with your remote machine, it won't like slow down your boot up times. So that is cool. So I'm going to leave that in there. So then we can save and quit out of here. And then I believe, yeah, we just run sudo mount -a. -a for mount just attempts to mount everything from your FS tab. So we'll mount that. I think that worked. It seemed kind of fast, but oh, yep, because it didn't work. Let me troubleshoot this for a sec and see what's cracking. Yes, that's right. I had to run sudo systemctl daemon reload because my FS tab was modified. Let me do that, and then I should be able to go mount A. It's still pretty fast. And bam, now our mount is successful, and every time your system boots up, it'll automatically mount this folder. Now what we need to do, we're almost there, is we need to use rsync and write like a little bash script to create our backups. So you're going to want to, rsync should be installed on like most Linux distributions, but you can just run a sudo apt install rsync just to make sure it is. And then let's do a little test backup to our folder. Let me open this up so I can see what's going on. And then we'll see the backups. Let's remove these test files just because I don't really need them. And then we're going to do a little test backups. We're going to run rsync -ravz. We'll back up my documents folder into /media/backup. And we'll run that. What these options do, -r will recursively back up, so it'll go into folders, like do it recursively. -a is archive mode, so that will just preserve everything exactly as it is, like file creation times and just like all the metadata around different files, as opposed to like normally when you copy a file, like it has a new creation time and all that sort of stuff. So this just preserves everything exactly as it is. V is just verbose mode, so it's going to print out all this stuff. And Z is a thing, it will essentially like compress data in transit, like while the backup is being made, and then decompress it once it ends up in its location. And because we're doing this over a network, this will kind of just speed up performance ever so slightly. So this looks like it has run. Bam, looks like it's completed. And if we go and look in here, bam, there is our documents folder, all done and dusted. Very cool. So we know Rsync is working, our backups are working because we have them in here. So the next thing is essentially to script this. Now, granted, if you really want to go like super manual, you could just run Rsync whenever you feel like it. But I wanted to create a script, partially just because just to learn more about, just practice. And then also because that will enable me to run this as like a cron job and automate it. So the script that I created is this one, rsync.sh. This will be in a link in the video and a link to my GitHub, and you can grab the script and look through it and see everything it does. I'm going to go over it right here. It gets a little convoluted down in the retention rules, not really, but kind of. So I'll try to explain it the best I can. You can also like grab it from my GitHub, look over it all you want yourself, throw it into ChatGPT or something, see what it tells you. So the way this script works is we've got the rsync command down here with our -ravz options like we had before. We've added in the -- partial, which just means that like if rsync were to like get interrupted or something in the middle of a backup, the partial file that it had copied will remain there, and then when rsync resumes, it can just resume where it was with that file. Then we've got the source directory. This is the directory that we want to back up, specified by this variable. In my case, it is my home folder. You can change this to whatever you like. Link destination. This is the thing that is going to create our hard links. It is specified by this variable, latest link, which the way this is working is at the end of the script, we create a symlink to our most recent backup. It takes backup name, which is like the backup that was just created, and creates a symlink to it that will then be looked at by rsync the next time it runs. So it'll look at the most recent backup made, look at the files in there, and whatever files are there, it will not copy those files. It will just match the inodes that they have and create a hard link to those old files. This way, when we do our backups, like I explained before, we only ever have to back up any file one time, which is very good. Exclude is just excluding folders or like locations that you don't want to back up. In this case, I'm doing cache and .local shared trash because I don't really want to back those up. And then backup name, this is the destination where our backup will be created. In this case, it is the backup directory followed by a timestamp. So the backup directory is that /media/backup, and date is this timestamp. The format I used is this one here. This format isn't actually the most usable, and it is a big chunk of the reason why this gets kind of convoluted down here is because you have to convert this into a more usable timestamp format. But I just feel like it's so much easier to like look at timestamps like this when I'm looking through my backups than in a different format. So yeah, so the backup name will be /media/backup/ whatever date that the backup was created at. And so that is the rsync command. And then where it gets a little bit more convoluted is down in the retention rules. The first thing we have is this get proper date function, which is just a function used to convert this timestamp into a more usable one. We'll kind of go over that maybe in a second. And then down here, you have this rule right here. What we're doing right here is, for me, I want to keep daily backups for the past 2 weeks. I want to keep weekly backups for the past, 6 months. And I want to keep monthly backups for the past 3 years. So what's going on first is we're creating like a set of variables. And what we're doing is we're using a find command in the backup directory, again, /media/backup. Max depth 1, which means it won't recurse into folders. It's going to look for type directories with a name of this format, which again is our timestamp format. It's going to look for directories where their metadata has been changed over 14 days ago, and then it's going to print everything it found onto one line with a null byte as a separator. It's going to feed that into a while loop where the separator is, again, nothing, is that null byte. And it's going to feed that into the dir variable. I don't know why I named it dir, but I did name it dir. So it's going to feed it into the dir variable. Then it's going to create this variable, dir date, which is going to get the base name of dir. And again, dir is going to look like /media /backup /August 15th, 2023, 1:16 a.m. And what base name will do is base name, is that on this virtual machine? That would be convenient. Yeah, base name will like trim off any like prefixes and suffixes of stuff. If you were to run base name user bin sort, you will just get sort. If you run base name include /standardIO.h, you will just get standard IO. So it kind of clips everything off. In this case, it's going to clip off the /media /backup, and you will just be left with August 15th, blah, blah, blah. So that is our dir date. Then we're going to go parse date. We're going to take this date right here, and we're going to run it through the get proper date function, which will essentially convert it into a more usable timestamp format. So then to get the day right here, so we're going to run a date-d on the usable date format plus d. So that will give us the day in the format of like day of the month. So like 1 through 31. It's going to get us then the weekday. So that's going to be 1 through 7. The week number in the year. So like 1 through 53. It's going to give us the month 1 through 12, and then the year, the year. So then we have a solid set of variables. For each backup, we can see what day of the month, what day of the week, what week of the year, what month, and what year for each individual backup. So once we have all those, we go into these two if statements. What we're doing here is, once again, we're doing that same find command. We're finding in the backup directory all directories with our timestamp format. And in this case, we're looking for directories where their metadata has changed over 14 days ago, but less than 168 days ago, which is 6 months. And we're printing all of that onto a line with a null byte as the separator. We're feeding that then into xargs, and then we are running, we're running that date that we got from those directories again into our get proper date function, and then running it into base name to convert all the directories we found into usable timestamp formats. And then we are running it into xargs again, and we are going to grab the, what is that the week number. So we're going to find the week number for everything. So what week of the year these backups were created, and then we're going to grep-c. So we're going to count the week number, and if the week number is greater than 1, and if the weekday is not equal to 1, then we will remove the directory. So what this basically does is, for any backups that are more than 14 days old and less than 168 days old and were not created on a Monday, we delete them. So anything over 2 weeks old, we just keep the Monday backup of that week. This if statement, hope that makes sense. Feel free to grab the script and pour over this as much as you want. This if statement does a similar thing. And granted, I'm fully aware that I am no master bash scripter. I am positive that there is a cleaner and easier way to do this, but this way works for me, and I like it because it is mine. But I look forward to the day when I'm even better and can write even cleaner scripts. This if statement does a similar thing. It looks for everything older than 168 days and less than 1,080 days, which is 3 years, and does more or less the same thing, just keeping one backup per month. So then once those retention rules are run through, we remove the symlink to the symlink that we had before to the newest backup and create a new one. So we take our backup name of the backup we have just created and create a symlink to it. So that way the next time Rsync runs, it will find that most recent backup and create hard links based off of it. So that is our backup script. So I'm going to quit out of there. And the next thing to do, the last thing really, we're almost there, is to just automate it. So the way you can do that is with cron tab to create a cron job. Cron job, if you don't know what a cron job is just a task that gets run on certain intervals of time. So yeah, so to edit those, you can just enter cron tab -e, and you'll get taken into here. The format for cron jobs, or for the cron tab, is the minute, the hour in a 24-hour format, the day of the month of the year, and the day of the week, and then the command. So if I want like this script to run, for example, every single day of the month, every month of the year, and every day of the week at 12 p.m. noon, I would go 0 for the minute, 12 for the hour, everything for the day of month, and day of week, and then the command, which will be this. And this will run this script every day at noon. If I wanted, for example, it to run every day at like 2:47 p.m., I would go 47 and then 14, because that is 2 p.m. in a 24-hour format, and then everything, and then home over to my script. So yeah, so then you can set up in here whatever format or like whatever interval you would like. If you just want it to run in like, February, you could do that if you're weird. Yeah, so you can set up whenever you would like to run this script. Very cool. I'm not going to save it. And at this point, you are good to go. Bada bing, bada boom. Give yourself a round of applause. Congratulations. You now have a basically from scratch cloud backup server that is all your own, that you can back up everything to, and you have full control over it because it's your computer. You can SSH into it. Bada bing, bada boom. Very cool. Who doesn't love that? Yeah. So I hope you learned something from this. I know this was a fun project for me. It was just kind of a cool opportunity to kind of get my hands on some cloud infrastructure stuff and mess around with that. It's definitely got me thinking about like some other like cool stuff I could do with this. Like it's a pretty cool tech that we can just nowadays just like fire up any type of computer we want in the cloud and just run stuff off it and do stuff with it. I think it's pretty cool. So it's definitely got my mind kind of like different projects and stuff that I could maybe do with this that I'm kind of thinking about. So yeah, so I hope you learned something from this. I hope it was informative. I know it was fun to make. It was nice to just be able to ramble about tech stuff. Not all of my IRL friends are as into hearing about this as I am, so it's nice to be able to just ramble into the YouTube void. So yeah, with that being said, keep it real, don't mess around, and I will see you in the future.